Okay, let us start. What we have discussed yesterday is the introduction of the electric charges and fields, and in that we have discussed what is a charge and its properties. So we are discussing the properties of an electric charge, and we also discussed the methods of electrification, that is conversion of neutral body to the charged body, that is called electrification. And we have three methods: friction, conduction and induction. So those are the three methods to convert a neutral body into a charged body. Okay, and we are also discussing the properties of charges. Properties of charges, we have already discussed three of them, that is charge is additive, charge is invariant and charge is conserved. Charge is additive, charge is invariant and charge is conserved. Now we are going to discuss the fourth property of charge, that is charge is quantized. Charge is quantized. This can also be called as quantization of charge. Quantization of charge, that means the charge on any body can be expressed as an integral multiple of charge on one electron. Okay? The charge on any body can be expressed as an integral multiple of charge on one electron. This can be expressed as, if Q is the charge on a body, then it can be expressed as Q is equals to plus or minus NE. Q is equals to plus or minus NE. Here Q is the charge on the body, and N is integer, whose values are 1, 2, 3, 4, so on. Whose values are 1, 2, 3, 4, so on. And E is the charge on electron. And why we express the charge on a body as the multiple of charge on an electron? Because the least amount of charge which is present on any particle is the charge on electron. Okay, so that is why we can express the charge on a body can be as the integral multiple of charge on one electron, and the least value of that charge is given by 1.6 into 10 power minus 19 coulombs. The charge on one electron is equal to 1.6 into 10 power minus 19 coulombs. So, the charge on any body can be expressed as the integral multiples of 1.6 into 10 power minus 19 coulombs. Okay, so this is called quantization of charge. Let us take an example. I think you have noted down. Okay, thank you. Consider a body is having a charge of 1 coulomb. A body is having a charge of 1 coulomb. Okay. Then how many electrons? How many electrons? So let the charge is positive charge. Let the charge is positive charge. Then how many electrons would have to be removed? Would have to be removed how many electrons would have to be removed to get this plus 1 unit of positive charge, 1 coulomb of positive charge. Okay, let us take the equation Q is equals to Ne. Then here we are asking to find out the number of electrons to be removed to get a charge of plus 1 coulomb. So N is equals to Q by E. N is equal to Q by E, and here the charge on the body is plus 1 coulomb and the charge on 1 electron is equal to 1.6 into 10 power minus 19 coulombs. Therefore, N will be equal to 6.25 into 10 power 18 electrons. So, 6.25 into 10 power 18 electrons have to be removed from that body to get that body a charge of plus 1 coulombs. Okay? Please note down. Okay, next one. Next, fifth one. The charge given to a body, charge given to a body always resides on the outer surface, of the body. So if we give some amount of charge to a body and that charge resides, where it resides? It resides on the outer surface of that body. That means consider if this is the body, spherical body, and we are giving charge to this body, a positive charge, then that whole amount of positive charge remains on the outer surface of that body. It remains on the outer surface of that body, and that charge is considered with respect to the surface area, that is the surface charge density, that is the charge per unit surface area, which is denoted by sigma. The surface charge density of the body is denoted by sigma, and this sigma is inversely proportional to the square of the radius of that body. Inversely proportional to the square of the radius of that body. If the radius of the body increases, then surface area of the body also increases. For example, in the case of sphere, the surface area is 4 pi r square. Therefore, if we increase the radius of that body, surface area of that body also increases. And whenever the surface area increases, the charge present per unit surface area decreases. Whenever the surface area of the body increases, the charge which is present per unit surface area, that is sigma, decreases. Okay? And next one, like charges repels each other, and unlike charges attract each other. Like charges repel each other and unlike charges attract each other. Okay, that means if we have taken two charges, plus q and plus q, two charges plus q1 and plus q2. So this plus q1 repel this one in this direction, and this plus q2 repel this one in this direction, because these two are like charges. If the two charges are unlike charges, then it will attract, q1 will attract q2 in this direction, and q2 will attract q1 in this direction. Okay? So like charges repel each other and unlike charges attract each other. And here we have to note an important point. That one is repulsion repulsion is the sure test for identifying the type of charge on a body. For identifying the type of charge present on a body. Okay. Why? Because in repulsion only we can find out the type of charge present on a body. Let us consider two bodies. First body, let it be A, and the second body, let it be B. Let the body is of positively charged, and we don't know what type of charge is present on the body B. Okay. Now we have to find out, we are asked to find out the type of charge present on the second body, that is on B. Okay. Now if we place the second body near to the first body, if we place the second body near to the, at a distance of some very small distance, very close to it, then if the body B is attracted towards the, if the body B is attracted towards the body A, then we can say B is having a charge of negative. Okay. B is having a charge of negative if it is attracted by the first body. Okay. For example, again, if the body is of positively charged and initially B is of no charge, B is of no charge, okay, then also if we place the second body near to the first body, then in this case also the second body is attracted towards the first body. Okay, so wherever in these two cases we are having attraction when the second body is of negatively charged or of neutral charge. Okay, in the two cases the second body is attracted towards the first body. So we cannot find out what type of charge is present on the second body, whether it is negative or neutral. We cannot specify exactly what type of charge is present on the second body in the case of attraction. Whereas coming to the case of repulsion, the first body is of positively charged and the second body, if we place the second body near to the first body, if it get reflected or repelled, okay, if it get repelled, then we can surely say that the body is of positively charged. Okay, understand? If the body B is repelled by the first body, that is A, then we can specifically or conformly say that the second body is of positively charged. But in the case of attraction, we cannot specify whether the body is having negative charge or no charge. In both the case, we can have attraction. Okay, in this case, because of induction, the second body, initially it is neutral, but after placing very near to the first body, due to induction, the body B will acquire a negative charge and therefore it will attract it towards the first body A. Okay, so that is why we consider repulsion as the sure test for identifying the type of charge present on a body. Okay, so like charges repel each other and unlike charges attract each other, and the repulsion is taken as the sure test to find out the type of charge which is present on any body. Okay. Okay.